welcome, Gershon, Sino, Zama. So nice to have you guys join us again today.
Welcome, everyone.
How are you guys doing? You can show either with your emoji, unmute yourself, share a bit on how your day went. Hi, Lutando. Nice to see you as well, although I see no audio. Can you hear us?
There we go. Welcome, Sino.
Hello, Sino.
Okay.
So while we're waiting for the others to join, we thought we'd ask you guys when your maths exam starts, if you haven't written it already. And yeah, how are you feeling about your first exam? So let us know in the chat or unmute yourself.
Yo, put the date.
Yes.
Like December or November 27th or whatever. And if you really want to be a superstar, put P1 for paper 1 and P2 for paper 2. Welcome, Zama. So while we're waiting for everyone, because I think, yeah, we'll wait a couple of minutes more. I have a whole bunch of questions that are kind of, so today is going to be quite flexible, and I don't mind adapting as we go, but we're basically going to be doing exam practice, but related to paper 2, based on the feedback in the previous lesson. But we're going to start with these multiple choice questions. We'll call this question 1, question 2, question 3, and question. These are all area, volume, perimeter type questions. And when you've got the answers, just pop them in the chat. So maybe your answer is like 1A, and pop it in the chat. You can also do that while we're also waiting for the exams, etc. So I can see Sino's writing the exam on the 21st, which is still 4 days. So you are in the right place. Paper 1 next Tuesday, that's for Zama. So next Tuesday would be sort of also mid-20s.
So let me
Gershon,
sorry, I said it's not Zama, it's Bandile.
Oh, it's Bandile. Ah.
Yes.
Gershon, have you written paper 1 and paper 2? Already, or are you still going to write paper 2 later? So for those of you who came late, we're just writing in the chat when your maths exams are, just so we can get a sense of the group, like, what your schedule looks like. Oh, you wrote both papers.
Wow. Cool. On one day. How did that go, Gershon? And while we're waiting for him, welcome to all the rest that we haven't said hello to yet. Sino, Saripa, Nokubonga, Kiki.
Oh, there's a wonderful
collection. Oh, one day. So good to see you all again.
Yes. No, it's a lovely big group. Awesome. Okay. So while we're almost ready to start, but what I said a few moments earlier is we're going to start today with these 5 multiple choice questions that are related to paper 2 and mainly area, perimeter, volume, etc. And I just want you to try and do these, and we're just about ready to start. So you just keep trying to do these questions, and then once you've done them, you pop the answer in the chat, and then we'll go from there. Okay, Alzan, anything else from you before we start?
Nothing from me. Thanks, Peter. Enjoy, guys. See you again afterwards.
All right. Awesome. Let's get rolling. Okay. So everyone, just to focus your attention, the main in question 1, what's a closed six-sided figure called? I want the answers up in the chat, please. I want to see active learners today. I want to see you participating. So answers are coming. Okay, coming through. Nicely done. You're absolutely right. First one is a hexagon. Okay, second question. So B is the answer for the first one, 1B. The second question, the barn family has a rectangular yard that measures 32 by 56. The length of material that they need for fencing is what? Now this relates to perimeter, and we've covered this in a previous lesson, but I want to see what you guys think. So we have 56, 32, 56, 32. And that will give us 112 plus 64. Let's just make sure my maths is correct. 112 plus 64, which should give us 176, which is B. So the second one is also B. Okay, so it's 1B and 2B. I'm going to give you a bit more time for question 3, 4, and 5. I was just kind of pushing you along with the first two. Now, one of the things we're going to talk about today is what's called unit conversions. How do we convert from one unit to another? And that's something which I haven't spoken about too much. You might have spoken about in your class, but we'll find out now. So let's 3, 4, and 5. So this box is a cube, and each of the sides is 50, 50, 50. But if we look at the answers aren't in centimeters. Okay, let's first actually look at the question. Gabe made a box in the form of a cube with edges 50, 50, 50 to cover it with wallpaper. So wallpaper, or we'll cover it up, is going to be the quantity surface area. So how much wrapping paper goes around the outside. But the one tricky bit is that it is given in centimeters, but the answers are all in meters squared. And so you might have to do some converting. So I'm going to give you a little bit more time. I see the first answers coming through. So there's two ways that we can deal with this. The one is to calculate the thing in centimeters squared and then convert it, or we can convert it at the beginning and then compare. So I'll actually do both. What is 50 times, oh wait, it's not going to be 50 times, okay. For surface area, ask yourself, how many faces are there? They're going to be 6. And each of those faces is going to be the same because it's a cube, and it's going to be 50 times 50 centimeters. So if I use my calculator, 6 times 50 times...
One moment. Okay, I found this on the web for faces is going to be the same B because the cube.
Oh my goodness. Sorry guys, my computer is just too eager. 6 times 50 times 50. Okay, so 1,000 or 15,000 centimeters squared. I know it's hilarious. The problem is that at the moment, none of the answers correspond to 15,000 centimeters squared. So what we need to do is convert it into meters squared. Now, I will teach you in this lesson how to convert between centimeters squared to meters squared. But in the interim, the easiest way to do this is actually just going to be to convert it at the very beginning. And so if I convert 50 centimeters, what is that going to be in meters? Can someone put in the chat? What is 50 centimeters if you convert it into meters? So I'll teach you this thing. King Henry died a miserable death called measles. Not everyone calls it like that, but so we'll talk about this conversion way. But basically, you should get 0.5 meters is 50 centimeters. So to get the answer in meters, we're going to go 6 times 0.5 times 0.5. So 6 times 0.5 times 0.5, and we get 1.5 meters squared. And it's B again. Oh my goodness. Are all these questions going to be answer B? Give me a thumbs up if you understood that. So it seems like 1.5 meters squared is the same as, okay, I see some thumbs, that's fantastic. So we need to come back to this later. 1.5 meters squared is the same as 15,000 centimeters squared. Now that's a big difference, and it might be causing some of you a little bit of a, what's going on there? And I wanted to, and I'm going to come back to it soon. Okay, question number 4 for the warm-up. The area of the shaded figure in centimeters squared in the diagram below is what? Let's get our answers here. So we have a big square. I suppose we want to know how it looks to me like this is 9 centimeters and this is 9 centimeters. Now, the problem is we're not after this one. If we wanted to know the area of this big one, it would be quite simple. It's just going to be 81 centimeters squared. But I want to know the shaded figure. So what I need to do is I need to work out what one of these is, and these are all going to be congruent. So I'll just times it by 4. But I need to figure out, how am I going to do this? Well, it's a square, so I know this is a right angle. If only there was a way to figure out, so that's 4. What's this going to be? We've got 4 and 5. So that's going to be 4, and so this is going to be 4. What am I doing wrong here? Oh, Pythagoras, that's 9. What do you guys think? How are we going to work this out? That's 4, that's 5, that is, let's have a moment here. I was thinking we could use Pythagoras in some way, but let's have a look. Let's see if I agree. So that is 5, and that's 4, and that is 5, and that is 5, and this is 4, and this is 5. So this is actually a bit harder than I originally expected. So do you agree with me with what I'm doing? Like, I'm trying to understand what the area of each of these triangles is. And according to the writing that I can see, this is 4 over here and 4 over here. This is 5 and 4, 5 and 5, and 5 and 4. So actually they're not congruent, but I can work out the area of each of these triangles. So the area of a triangle is just a half base times height. So let's do this one. Let me get a color so that it's not confusing. Let's work out this one over here. A half, 4 times 4 is going to be 8. So that's that one taken care of. Now, the next one is going to be a half times by 4 times by 5, which is going to be 10. So I'm going to put things around these so we don't get confused. Then on this side, the 5 by, let's use another different color. What should we use? Oh, I'm running out of colors here, guys. Okay, I'm going to have you just follow along with me. This one is going to be a half times 5 times 5, which is going to be 12.5. And then the last one here, 5 times 4, we've already got. So a half times 5 times 4 is going to be 10. So I think I've got the area of the big square. And if I add up all of these things, this should be the area of the triangles on the outside. So 8 plus 10 plus 12.5 plus 10, I get 40.5. Oh my goodness. Okay. So if I go, I think there's a mistake in this question, but we can learn a lot from it, even if we just go through the process. So in the final thing, all I'm going to do is I'm going to say 81 minus 40.5, which is equal to 40.5. I think there was a mistake in the question, but the only thing I wanted to show you was to find the shaded region. All I did was I took the big thing and then I took away the things on the outside to find the thing on the inside. So again, just give me a thumbs up if my method made sense. I think what happened was when I copied the question across, the 4s and 5s might have been in the wrong place. Give me a thumbs down if you feel very confused by what I actually did. All I was trying to do was I was trying to show you to find the shaded region. You take the big one and you subtract the triangles. That was the main idea. But I might have got a little bit excited along the way. Okay, then the last one, maybe, what is the area of this parallelogram? What's the formula for area of a parallelogram? So I'll wait for the answers. I want 5A or 5B or 5C. How do we find the area of a parallelogram? We did it in a previous lesson. It's going to be base times perpendicular height. So what answer is that going to give me? Any answers, everyone? Any ideas? I feel like I've been talking to myself for a while. Aha, I see some answers coming through. So all I need to do, this is the base, and this over here is the perpendicular height. So we go 12 times 4, which is 48 meters squared, which is C. And that's it. Okay, so let me do a little bit more teaching now and a little bit more explaining. But this is from the section in paper 2 for area, perimeter, volume, surface area, and so on. So one of the things I want to talk about is converting units, because it is going to come up in the lesson today. So I'm just going to give you a little explanation, and then I'll see through thumbs up or thumbs down who's done it before. So the way most people get taught is they get taught with this kind of, they have a different ways of saying it, but I always remember King Henry died a miserable death called measles. And the thing in the middle is the meter, the SI unit. Now, if I go to the left, it's for every hop, it's a factor of 10. And if I'm going in this direction, the units are getting bigger. If I'm going in this direction, the units are getting smaller. So let me give you an example. If you have 3 meters and you want to convert that to centimeters, you have to go 2 hops or 2 factors of 10. Now, when you're going in this direction, you're going to smaller units. So what's going to happen is, because things are getting smaller, there are going to be more of them. And so what I do is I go 3 times by And you can either say 10 times 10, or the fancy way of saying it is 10 to the power of 2. I don't know which one you would prefer, but maybe it's even better to do it like this. So, and that's because there's 2 hops that go like this. And so you see that, in fact, 3 meters is equivalent to 300 centimeters. So you need to make sure that you have this idea clear. So I'll do another one with you now. Let's say I gave you let's make it 2.4 kilometers, and we're converting it to meters. Can you put the answer for me in the chat? What is 2.4 kilometers in meters? Using this system. So I'm assuming that you know this is kilo, this is hectare, this is deca, this is deci. Let's actually just check I got that the right way around. This one is definitely centi, this one is milli. Okay, well done, guys. So because you're going now from a big unit up here, and you're going 1, 2, 3 jumps, all I need to do is take 2.4 and times it by 10 times 10 times 10, or do it 3 times. And the fancy mathematical way of doing that is timesing it by 10 to the 3, or timesing it by 1,000, and you'll get 2,400 meters. Okay, now that's the basic idea. But what if we go in the opposite direction? So what if I gave you, let's say I gave you 562 millimeters, and I want you to convert that to meters. So now you are going to be up here. Here's the milli, but you're going in this direction. So I want you to try and figure out what is 562 millimeters converted to meters. So think about this. You're going from a small unit, milli, really small, and you're going 3 jumps or 3 factors of 10. But because you're converting from a really small unit to a really big unit, you're going to have less of them. So that's my hint. So what do you do when you're going the other direction? When you're going from, I'll give you a bit more time, but just think about that. Okay, so you go 562, and instead of timesing by 1,000, you divide by 1,000, and you get 0.562 meters. Okay, so that wasn't so bad. And whenever you do this, ask yourself that. Ask yourself, how many jumps do I have to go? For each jump, it's a factor of 10. And then ask yourself if you're going from a small to a big or vice versa. Okay, so let's look at an old exam question to practice this idea. Because you'll see how it gets tested in the old exam. Wait. Okay. I want you to do this question for me. This is from an old exam. You can leave out this bottom bit. I'm not worried about that. I just want you to do the 3 marks here. So go ahead, 6.1, 6.2, 6.3. And 6.3.1, I want you to give me the answers for this in the chat, and I'm going to give you some time. I'm going to get some water. So where are we? We're centimeters. So we're at centimeters, which is here, and we have to convert to millimeters, which is here. So that's for the one. And then for the other one, we need to, okay, so in this case, instead of having meters, we're going to have grams. But we need to go from here all the way down to here. So when we're weighing things, or when we're dealing with mass, instead of measuring meters, we're measuring grams. And then the last one is find the perimeter of the shape. Okay, so for centimeters to millimeters, because we're going one hop of 10, we only have to either multiply or divide by 10. Because it's smaller, because we're getting smaller, there's more of them. So we're just going to get 4.75 times 10, which is 47.5 millimeters. And I see in the answers, I see people getting 47.5, which is good. For the kilograms into grams, it's going to go 3 hops. 1, 2, 3. And again, we're going from a big unit to a small unit. So we're going to multiply by 10 to the power of 3, or if you like, you can write that as 1,000. Both are the same. And we'll get, brain's feeling lazy, 560 grams. And then, see, I see that answer. So let's the perimeter of the shapes. So the perimeter is, remember, perimeter is around the outside. So this will be 50 and this is 40. So to me, this looks like it would be 180 centimeters for the perimeter. Okay, so watch out for the wording. Yeah, perfect. Okay, so that wasn't so bad, hey guys. That was pretty good. I think we can actually move on from that, because there are other types of questions, but I just want to get to that. I tell you what, I want to find one where I'm converting it to, okay, let's do this. Let's take it up a notch. Okay. Can you all see the shapes here? I want you to find for me the volume of this over here. And I want you to try, after that, to try and find the surface area. Now, notice how I'm jumping a little bit here. Volume is how much space the stuff takes up, both of these. And surface area is how much goes around the outside. Okay, so everyone is going to try and do number 2. And I'll give you some hints if you need them, or you can actually jump online and ask a question, but see if you can do 2 by yourself. And that's a pretty decent question. I'll give you some time to think about it. So my tip is to think, how would I work out the volume of the lower bit, the rectangular prism, and how would I work out the volume of the cube? And could you put them together? And then I want you to choose the right units too. And then once you've got the volume, try and see, can you find the surface area of the compound shape? And remember, the surface area is what's exposed to the outside. So let's do let's try and think of the volume here. So the cube's volume is just going to be 4 times 4 times 4. So that's nice and easy. And the plus, the volume of the rectangular prism is going to be 4 times 8 times 5. So what's that going to be in total? I might have to use my friend the calculator if I can't do this in my head. I think this is 64. And I think, well, that's 32 times 5, which I think is 110, but let's see. Oh no, so good thing I checked, 160. So together that should be 224, and the units should be meters cubed. Okay, so meters cubed. So well done, everyone. I see that the volume we're getting nicely right. Now, what about the surface area? And watch out for, when you put things on top of each other, what does that mean for the surface area? So the thing I want you to watch out for is what's happening over here, and how do we deal with that? And I want to give you a chance to try and figure this out by yourself. So think about it. Actually, oh, sorry, guys. So to make this a bit bigger. Oh, there we go. So let's think about how many faces does the rectangular prism that are normal? I think there's the front and the back, the side and the side and the bottom. So 5 of the faces are behaving like normal. But this top one over here, it's behaving a bit more because it's kind of being blocked by this. And then we think about this shape, how many faces does it have? Okay, so that should give us a little bit of a hand. And we can do it like we did last time. If we think about the cube, how much of the cube is actually facing the outside that would need to be wrapped? I think there are only 5 faces of the cube that would need to be wrapped. So we're going to go 5. Let's get rid of the volume actually, because it's just getting in the way. We need a bit of space for the surface area. So basically, if we have 5 faces, because the one is covered on top of the rectangular prism, and each of the faces is 4 times 4. So that would give me the surface area of this cube. Now, to find the surface area of the rectangular prism, I need to think a little bit more. So maybe I should even slow down. So I think this is going to be 4, and that's going to be 5. And there's 2 of these. So I'm going to say 4 times 5 times 2. And that's going to get me the front and the back there. Then I'm going to say, there's this front bit here that is facing me. How big is that rectangle? I think it is 8 along, and how far is it up? It's up 5. So plus 8 times 5, and there's 2 of them, so we times it by 2. So now we've got the front and the back taken care of. Now, what about the bottom? Well, the bottom, for the sake of color thing, the bottom is going to be, what's that going to be? It's going to be 8 like that, and it's going to be 4 across. So plus 8 times 4, and there's going to be another one on top. But there's a problem with this, because some of that top bit is covered up. And so we're going to have to take some of it away. In fact, how much are we going to have to take away? We're just going to have to take away one of the faces of the cubes, which is just going to be 4 times 4. Okay, so there's a lot going on, so I'm just going to run through this again. This is the cube up here. Then there's 2 rectangles, which is this red part. There's 2 green rectangles. There's 2 blue, but then because of that bit that's covering it up, we have to take that away. And so now we have to bring all our answers together. So we get 5 times 4 times 4 is 80. I'll put units in at the end. So that's the one bit. And then 4 times 5 times 2 plus 8 times 5 times 2 plus 8 times 4 times 2 minus 4 times 4 is 168. And so together, we should get 248 meters squared. Okay. Now, I wonder, can you see how that was a hard question. Now I want to ask where, I'd love somebody to jump online and maybe give me a question, or if you felt like you followed me, give me a thumbs up. Or if you have a question, put it in the chat. I'll try and show you. So this was the cube. So this was the 5 faces of the cube. And that was 80. And then I had to go and work out with those rectangles. So give me a thumbs up if you're sort of following me. Give me a thumbs down if you feel like, oh, this is too much. I just want to get a feel for the group. It's time to show me with your voting. Okay. See a couple of thumbs. Don't be afraid. You can vote thumbs down. You won't hurt my feelings. I just want to get an honest sense of, I'm trying to show you the method you can use when you have, we call these compound shapes. Okay. Well, I'm going to move on then, because I feel like I've given you a good taste of quite a difficult question there. Okay. I want you now, let's put that one out of focus. I want you to work out the volume of this compound shape. So this is a compound shape in that it's not like a neat little thing. It's a combination of shapes. And I'd like you to try and work out the volume, and then we'll do some unit conversions afterwards. Let's see what the chat stream says. Okay. Now watch the question carefully here. This is volume, not surface area. Now volume is how much stuff fits inside here. If you were stuffing luggage inside this, it's not the wrapping paper one that I often think about, which is a surface area. That's a different question. What would be a good way to do this? There's actually more than one way. If I wanted to work out how much stuff, how many Smarties or how much stuff I could fit inside here, what would be the best way to calculate it? I've got some of the dimensions. I've got 8 over here. Oh, I wonder, I see your question. You had the same working out, but a different answer. Possibly one of us made a calculator mistake then. So we can always go back and look at the video again. Either you or me made a calculator mistake when we were adding up, but the working out is good. So just go back and have a look and see if you might have made an adding up error, or maybe I did too, but we'll have to check. So I think one way of doing this is to think about this, what it would look like if it had this whole block here, and then asking how big is the red block that we essentially chopped out. So that's one way of doing it. Okay, so how big is how big would the whole thing be if it was in, and then how much do we take away? The other way of doing it could be to say, okay, well, could we think of the bottom and then think of this thing that's poking out over here, and then just add this to the thing on the bottom. That both ways will work. Which way would you prefer me to do? So if you want me to, I'll call it the additive way. If you want me to add it up in 2 pieces, give me a happy face or a thumbs up. If you want me to take things away to get this, give me an unhappy face or a thumbs down. Okay, so you want me to, You want me to break it into 2 pieces and add? Okay, fantastic. All right. So if I want to do that, the dimensions of the bottom one are going to be 4 across, 3 up, and 8. So the volume of the bottom bit is 4 times 3 times 8. Okay, so that's the bottom bit. But we have to add this top bit here. Now it's still going to be 8 deep. It's going to be 2 across, and it's going to be 2 high. And the reason it's going to be 2 high is that we're comparing the, let me change colors so that the 3 over here and the 5 over there mean this must be a 2. But we also know that's 2 across, and we know it's 8 long. So we'll say plus 2 times 2 times 8. And so then we'll get 4 times 3 times 8 is 96 plus
100
2. Huh? Jump on. What was it?
128, I think. Yeah.
Smashing it. Well done. 128 centimeters squared. And that's the volume of this. So what that literally, oh wait, no, it's not squared. It's, oh, I almost
Volume. Centimeters
volume.
cubed.
Perfect. 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 It's centimeters cubed. It literally means that there are 128 little cubes of 1 centimeter by 1 centimeter by 1 centimeter that would fit inside here. Like literally, if you imagine 128 of them fitting in there. Okay, now I'm going to be a sneaky teacher. I am going to do a unit conversion using this quantity. So we know that there's 128 centimeters cubed in this thing. What if I said to you, I want to convert this to millimeters cubed, okay? Millimeters cubed. Now, notice how we're not talking about perimeter. We're converting units that are cubed already. What do you think the answer is for this shape if I asked you to write it in millimeters cubed? I want you to try and have a go at doing that and then writing the answer in the chat. So converting 128 centimeters cubed into millimeters cubed. And there's a slight catch with this one. So I'll draw this at the top. King Henry died a miserable death called measles. And we know that we're over here and we're going to here. I wonder you are on fire because you, okay. So the thing to watch out for is if it's getting bigger and smaller, but also what is the effect of this cubing thing? Because when you're dealing with units that themselves are cubed, that has an extra complicated, an extra thing that gets interesting. So I'll show you now in a moment. So I think you'll all agree that going from centimeters to millimeters means you're getting smaller. It's 1 hop of 10. Okay. Oh yes, yeah. So I'll do the answer now. So it's 1 hop of 10. So, and because you're getting smaller, there's going to be more of them. So you're going to times 128 by 10. But you don't just times it by 10. We all know that it's much bigger than that. So how do we know how much bigger to make it? Now, because we're dealing with cubic units, we cube the conversion factor. So I'll say that again. It's only 1 hop, and 1 hop is multiplying by 10. But because of the fact that we're dealing with cubic units, I need to cube my conversion factor. And so what happens is the final answer is going to be 10 cubed is 1,000. So it's 128,000 millimeters cubed. And that is a little bit confusing. So it's 128,000 millimeters cubed. Now I'll do another example because I know this is a bit weird at first. I want you to convert the 128 centimeters cubed. I want you to convert that now, not to millimeters cubed. I want you to convert that to meters cubed. So we're converting it to meters cubed. And I want to give you a moment to think about that. So now we're going from centimeters up to here, but that has quite a few effects. 128 centimeters cubed. So we're trying to get, what is that in meters cubed? Okay, so first of all, we need to decide, are we dividing or are we timesing? So because we're going from a smaller unit to a bigger unit, it's actually going to get less. And so what's going to happen is you're going to be dividing. Okay, so you're taking something small and you're expressing it as a fraction of something which is bigger. So the actual unit's going to get smaller. So you divide is the thing you need to do. Now, how many hops has it been? It's been 2 hops of 10 or 2 factors of 10. And so normally you would divide by 100. But there's one more complicating factor. In this case, because you're dealing with cubic units, you are going to cube the conversion factor. Okay, so I want to go over that again. Why am I dividing? I'm dividing because I'm going from a smaller unit to a bigger unit. And so this smaller unit is going to appear smaller as a fraction of the bigger one. So I divide. How much do I divide by? I divide because of the 2 hops. I divide by 100 or 10 to the power of 2. But then on top of that, because it is cubic units, I need to raise that to the power of 3. So this is actually going to be, now what is 100 to the power of 3? It's actually going to be, that. So 128 divided by that, I can use my calculator. That's actually 1,000,000. So 128 divided by 1,000,000, essentially, 0.000128, and that's going to be meters cubed. So I would advise you to watch this video again, but this method works perfectly. You just have to practice it. Okay, and it may look a bit strange. So I'm actually going to do an example with you with area showing this method as well. But give me a thumbs up or a thumbs down, depending on how you're feeling at the moment. Are you following me? Are you sort of following my method? We're going to do another example now to practice. Okay. Okay, so let's do area because we haven't done area for a while doing unit conversions. So I'm not going to do a massive amount of area. Let's just talk about this surface out here. That surface is one of the faces of the shape, and you can see quickly it's 24 centimeters squared. Now, if I asked you to convert that to meters squared, notice how the units are no longer cubes. We're talking about area. What would 24 centimeters squared be converted to meters squared? And I want you to use the same method as before, but just adjust it slightly. Now, the other thing you could also do is you can convert your units at the very beginning. So you could convert your centimeters into meters at the very beginning, if you like, and then it'll have the same effect. But for now, I think this method is a little bit more flexible and powerful. So the amount of hops I have to do is still 2. But am I going to be dividing or am I going to be timesing? So you should have got, I'm going to be dividing. And I'm going to be dividing by, because it's 2 hops, I'm going to divide by 100 because it's 10 times 10. But because the units are squared, I have to square the conversion factor. So I'm actually going to say 24 divided by 10,000. And what do you get then? Let's have a look at the chats. Okay, you should indeed get, move it 4 decimal places. You get 0.0024 meters squared. Okay. So again, I would practice this approach, but I think I've given you a decent rundown on how to approach it. If you really get stuck, remember, you can also just convert, just to show you that this does work, right? If I converted centimeters into meters at the very beginning, 3 centimeters as a fraction of a meter is 0.03. 8 centimeters as a fraction of a meter is 0.08. If you multiply 0.03 by 0.08, you get 0.0024, which is the same answer as before. So both methods give you the same answer. It's just that the one is a bit more adaptable and flexible. Okay, so we're almost done for today. What I'm going to do is I actually want to get some feedback about what to do in the next lesson. So, okay, I've made a little exit ticket for you, and I want you to do this by yourself, like kind of straight away after this lesson. So just take this code down, join my quiz, and then 33261793. And I want you to then give it a go and see how it feels. But then what I would love for this last sort of we've got about 9 minutes left. We are doing a exam preparation unit from next week. And I would love for us to talk about those areas that you want me to concentrate on. So I'm going to be doing old exam papers. And what I want to know, how do I best, what would you like me to focus on so that you get the best, learning in this time? Okay. So what you can do is just check that you've got this code written down. I really recommend doing this straight away this evening. And then I'd like to just take a moment before I hand over to Alzan. I'd love to hear, what are you wanting me to do next week? I realize some of you almost have written already by next week, but I know this stuff is going to come up again in grade 9. It's not going anywhere. And so even if you have written already, it's worth your time to be here. But especially if you haven't written, you can dictate what's in this class. And brownie points for the people who jump on the mic. Because tonight it just felt like I've said a lot. I'm hearing my own voice too much. Okay, over to you guys. What do you want to talk about next week? Do you want to talk about data? Do you want to talk about algebra? Do you want to talk about equations? Just give me some clues. Otherwise, I will use my experience to do the areas that traditionally students struggle with, but I'm absolutely flexible to adapt to what you guys want to do.
Good evening, sir.
Hello. Who is speaking?
It's Sino, sir.
Sino, go ahead, Sino. What can we do for you?
Sir, my maths teacher told me that we're gonna be writing. She didn't give us a specific scope. She said we should study the year's work. So
okay. Is there any area in particular that you'd like to go over in a bit more detail? For example, one of the things I was going to maybe do I have lots of old exam papers, and on the Watobe app, you should be practicing with old exam papers. You can even, okay, straight line graph from Abdullah, that is perfect. Also, Abdullah, do you know that I actually did a series on graphs already? So I will absolutely do more questions, but if you go to the YouTube app or the YouTube Watobe channel, I did 4 lessons on graphing. And so I would highly recommend before the next lesson, have a look at those. Okay, but I will absolutely do straight line graphing questions in the next lesson. What else?
Could you also do ratio?
Ratio. Oh, always a tricky one. Okay, so ratio, absolutely. What else? Okay, so guys, what you can do is if you let Elzan, can they send you messages? Like, I don't quite know how it works. If they want to like, you know, sort of push the direction of the next session, how would that work?
So are you speaking about messages on the Zoom or messages on the app? Because they can send me
So
messages
for
on
example,
the app.
yeah, so if they wanted to influence, okay, they can send you a message on the app, yeah. Okay,
Hmm.
perfect. So guys, if you then, after you're practicing or you're doing a question from the old exam papers on the Watobe app, just go ahead and, you know, I will, based on the feedback I get from you, I will adapt. Okay, cool. It's been a lot of fun doing this. I hope that that was helpful to some degree. Ozan, I'm going to hand over to you, and yeah, thanks very much. I'll stop sharing.
Awesome. Thanks so much, Peter. So from my side, there's not really anything that I'd like to share. I just love to hear from some of the learners who maybe didn't hear at the start. When are you guys writing your first paper and your second paper? So you can either put that on the chat or you can just unmute yourself and let us know. So I've already heard from Sino and from Bandile and Gershom, who's already written.
Yes. Also, it was quite nice yesterday, maybe after we've heard from the students, to just show them where the old exam papers are in the Watobe app. I don't know if they all know, maybe they do, but just to make sure that, because sometimes new students are joining all the time.
Yeah,
So,
that's
but
very
I don't know if
good.
that's
I
available.
can do that.
Yeah.
Of course, no, that is available. So I'm getting a lot of messages on the chat. Thank you so much for sharing, guys. One says they only wrote one exam and it was yesterday.
Okay.
Duna said we wrote our first paper today. Bandile says there's only one paper.
Oh, okay.
Peter, do you have any questions on these replies?
So my, I would love to get some feedback, but I'm trying to think about how the best way to do that. So how about, could you put in the chat one thing you really enjoyed about the session, or if you enjoyed something, and one thing you think could be done differently you're to improve, or something, you know, basically one thing that you liked and one thing that you think we could change that would make it better for you. That would be super helpful for me. Because when you're a teacher, you still keep on learning. And the way I learn is partially by getting feedback from students and partially from reading about what good teaching looks like. So that would be awesome. And don't be shy. I like real feedback. So.
Sorry, I'm trying to go onto the grade 8 lessons now. I'll share my screen in a moment. Okay.
No problem. I'm just wait. Sometimes it takes a bit of time to type people's feedback.
It does take some time.
Let's have a look.
Okay. So let me share my screen.
Yeah.
For the learners who are not yet aware of the past papers, so you can go onto your Watobe app and you can go here next to the topic bar, there's a skills bar. So you just go into that skills bar and you'll find Watobe's library. As you hop on there, you go into exam papers. and then mathematics. Then we are in grade 8, so we choose this option. And here you will find different topics, algebra,
That's great.
finance. So you can choose the topics, you can work through them all, and you'll find that there's memos as well. So if you have any questions or if you're uncertain, you can just go and look at the memo afterwards.
Yeah, no, that's
Okay.
exactly it. Yeah. Awesome.
Awesome. Well, guys, thank you so much for joining again. We are looking forward to seeing you again next week to go through some of those questions and the topics that you have all been wondering about. Peter's there to assist you as much as he can. And yeah, if you have any questions during this week, feel free to send a message to me on the Watobe app. You can just go onto the chat here and then you just type in and say, hi, Alzon, and then message whatever you want to message, okay?
Yeah, and if they want to like tell me what type of topic they would love to see, then you can always pass it on to me. Yeah.
Yes, I will do. Okay, guys. Well, enjoy the rest of your evening. Take care.
Cheers. Bye, Zon. Bye, Sino.
Peter.
Bye, Gershon. Bye, Ayabonga. Awande. Bye, Lutando.